Hey CW Apes, Mr. Kennedy here. This is your Chapter 19 video lecture notes on water pollution. Today we're going to spend some time talking about this amazing liquid. It's polar, it's the universal solvent. It'll pick up and take on just about anything we put into it, which is both a blessing and a curse if you really think about it. If you think about water pollution in this way, well, basically anything and everything that goes into this stuff can be carried by this stuff with a few exceptions. Sometimes water pollution can get so bad the water itself can actually catch on fire. That's what you're seeing in this picture. We're going to spend a little bit of time today going through point versus non-point sources of pollution, and then eventually get to where we're looking at water legislation and ultimately what we're doing to protect our water. So let's dig in, okay? First thing I want to define for you is, what is water pollution? Water pollution is any physical, biological, or chemical change in water quality that adversely affects living organisms or makes the water unsuitable for desired use. And I know what you're probably thinking. Well, Mr. Kennedy, look, that kind of stuff never happens where I live. I mean, I don't even live near a body of water, so how could I be a problem when it comes to water pollution? At the end of the day, you're probably right. You could probably live where we live or where you live your entire life and never see what I'm showing you in this picture. But that's not the only kind of water pollution that's out there. Yes, that's one form of water pollution where people will just walk up to a body of water and pour whatever they got into it. But probably a bigger problem than that is what goes on in our own homes. You know, somebody just pours paint or oil down a drain or some sort of household cleaner that, is toxic to other living things, and you've got water pollution. That's how it starts. Then it travels to wastewater treatment facilities or basically like to local rivers, waterways, and can create pollution. There's two types of water pollution that I want you to consider. One is called point source pollution, the other non-point source pollution. In point source pollution, the discharge comes from a specific point into the environment through pipes, sewers, or even ditches from a specific factory. At the end of the day, point source pollutants can easily be tracked back to their point of origin. Non-point source pollutants, much different story. This is land pollution that enters a body of water from large areas rather than a single point. Agricultural runoff, mining waste, any and all types of urban runoff that goes down gutters and ends up in waterways is a non-point source pollutant and hard to track down. If we just expand our look at non-point source pollutants, let's look at this: atmospheric deposition. Atmospheric deposition includes contaminants that are carried by air currents and precipitated into watersheds directly or indirectly into the waterways. It can come down as rain, snow, or even dry particles. And I know what you're thinking. That's not fair. What if I'm doing everything I can to take care of the water where I'm at, and some local yokel somewhere else isn't? Yeah, I know it's not fair, but you can inherit their water pollution through the air. It's estimated that 600,000 kilograms of herbicides have actually ended up in the Great Lakes from just such a scenario. The other thing that you need to keep in mind is that once the water's polluted, well, the contaminants can actually evaporate from the waterway, go back up into the air, and continue to travel. Next thing I want you to take in consideration is infectious agents. The main source of water-borne pathogens is improperly treated human waste. Animal waste from feedlots and fields is also an important source of pathogens. At least 2.5 billion people in poor countries lack adequate sanitation, and about half of these lack access to clean drinking water. I know it sounds gross, but at the end of the day, there are countries that still dump raw sewage directly into our oceans. The developed world, like the United States, we're considered a wealthy country, and we do a pretty good job treating our wastewater. Very rarely would you ever have a situation where wastewater in a developed country would end up in a body of water. But every once in a while, it does still happen. Not that long ago, the wastewater treatment facility in the San Francisco Bay Area in Marin County actually overflowed. It had no other option than to vent raw sewage into the San Francisco Bay. Now, it wasn't just because they wanted to, and it wasn't just because like the Bay Area all of a sudden produced lots of sewage. It was a combination of things. There would have been lots of rain, and couple that with the regular sewage inflow, and there just wasn't enough time to treat all the waste, and yeah, the rest is history. One thing that we can look for in terms of infectious agents in water is coliform bacteria. Coliform bacteria is an intestinal bacteria that, if present, is a good indication that your water is contaminated by fecal material. Drinking water in the state of California, as well as many others in the United States, is often treated with chlorine to help kill coliform bacteria and to prevent us from getting sick. In places where chlorine is either too expensive or frowned upon because of its flavor, well, then they use UV light. Next thing I'd like you to consider when you think about water pollution is the Great Pacific Garbage Patch. The Great Pacific Garbage Patch is an accumulation of plastic and garbage in the ocean. Plastic and garbage accumulates in what are called gyres, or basically circular moving currents in the Pacific, as well as some of the other oceans. And the Great Pacific Garbage Patch, as it swirls in the northern Pacific, has accumulated about a 4 to 6 foot deep patch of garbage plastic that is now twice the size of Texas. That's right, that's the biggest state in our union, and this garbage patch is 2 times the size of the entire state. So 2 of Texas is sitting out there in the Pacific. If you want a European reference, well, then it's 3 of France, okay? So, and it's like anywhere from 3 to 6 feet deep. Estimates say that even if we stopped putting garbage into the Pacific today, we would never be able to get all of the plastic that's out there out of the ocean. Part of the reason is because no one wants to claim responsibility for the trash. It's going to be expensive to clean up. And the other part is that since it's plastic, well, while it's not decomposing completely into the water, it is breaking down into smaller and smaller particles that we call microplastics. Those microplastics, well, they're nearly impossible to filter out of the seawater and are currently traveling up through the food chain. Many humans have microplastics in circulation right now, and it could just be because you've drunk water that has microplastics in it, or you've eaten food that has drunk water with microplastics in it. By the year 2050, if we don't change the way we're behaving when it comes to garbage in the Pacific, well, the statistics don't lie. There will be more plastic in the ocean than there are fish. That's a problem. That's something to consider. Every minute of every single day, there's a garbage truck size load of trash that gets dumped in our ocean from somewhere along its coastline. Next thing I'd like you to look at is turbidity. Turbidity is sediment, basically dirt, that ends up in our waterway. We get dirt in our waterways as a result of erosion. Now, it might sound like, what's the big deal? It's dirt, it's erosion, it's a natural thing. But remember, anything that is in that soil would then be dissolved into the water. Not only that, but the soil itself can reduce light penetration in aquatic ecosystems and literally, fill those, waterways up. Rivers, lakes, and streams can slowly fill in with this sediment. It's human activities that are largely responsible for the erosion rates in many areas. Human-induced erosion and runoff contribute 25 billion metric tons of sediment and suspended solids to the world's surface waters each year. And again, they can obstruct shipping lanes, they can clog hydroelectric turbines, they can smother fish eggs, block out light needed for photosynthesis. The list goes on and on and on. The one possible plus of this sediment moving downstream is it might rebuild wetlands and provide nutrients to nutrient-depleted waters downstream. This is just a picture of what it might look like if we compared a clean body of water to one loaded with sediment. You can see without the light penetration and without photosynthesis, the entire ecosystem falls apart. All right, moving on. The next thing I'd like you to consider are inorganic and organic chemicals. Inorganic chemicals include heavy metals like mercury, cadmium, nickel, and selenium. Their sources are lead pipes, gold mining waste, industrial processes, and occasionally that which occurs naturally in the soil. Most of these heavy metals are neurotoxins, which means once ingested, they go straight to your nervous system and can literally lead to a wide variety of maladies. One such malady is Mad Hatter's disease from absorbing mercury through your skin. You might remember the movie Alice in Wonderland, the Mad Hatter. He's called the Mad Hatter not because he's angry, but because he's literally insane. Back, decades ago, mercury was used a lot in the textile industry. And so if you were making hats, especially colorful ones, a lot of the pigments and dyes that they used had mercury in them. You would likely absorb some of that through your skin, and, well, the rest is history. Mercury, as well as cadmium, nickel, and other heavy metals, are also persistent in the environment, which basically means once they're out there, they're not going anywhere anytime soon. Okay. Many metals can also bioaccumulate in food chains and biomagnify. If you don't remember what bioaccumulation and biomagnification are all about, go back to that video that I covered that in. I'll sum it up this way. If mercury is in the water that I'm drinking, the longer I live in that water, as a fish, let's say, the more mercury I'm going to accumulate. That's bioaccumulation. If I live in that water for a long time period and then a fish eats me or something, well, then that fish is going to get a mega dose of mercury from that which is stored in my tissues. That's biomagnification. Most widespread toxic metal contamination in North America is mercury-based. Okay, about 600,000 American children have mercury levels high enough to cause mental and developmental problems, and 1 in 6 women have blood levels high enough to harm their fetus. Mine drainage and leaching of mine wastes are serious sources of environmental contamination and one of the primary causes of all of this mercury contamination. In a Tennessee study, 43% of streams and 50% of groundwater was contaminated by metals and acids from mine drainage. Non-metallic salts, let's look at those next. Non-metallic salts are things like selenium and arsenic. Selenium and arsenic are non-toxic at low concentrations, but they can be mobilized by irrigation and concentrated by evaporation, reaching levels that are toxic to plants and animals. Road salts are a great place that we can get selenium salts. Arsenic is something that we find in the soil, right? It's in high concentrations in places like Northeast India and Western Bangladesh. Acids. Acids are often released as byproducts of industrial processes. Coal mining is a big culprit when it comes to acid mine drainage. Coal mining puts this acid into the surrounding rivers, lakes, and streams, and if the pH drops just below 5, we can honestly end up with a completely sterile environment. Another place that we get acid deposition that's different than the coal mine itself is from the combustion of fossil fuels. The combustion of fossil fuels puts sulfuric acid and nitric acids up into the atmosphere. They mix with water, come back down as acid rain. Okay? Thousands of lakes in northeastern U.S., Canada are literally empty of fish and support only a few mosses and fungus because of their low pH. This will kind of give you an idea of what those processes, that acid mine drainage, looks like. Next thing I'd like you to think about is organic compounds. These are your pesticides, oils, plastics, pharmaceuticals, pigments, detergents, cleaning solutions, and paints that end up in our waterway. Remember, water is the universal solvent. It's this amazing liquid, and it'll pick up and carry with it just about anything you put in it. Organic compounds, like the inorganic compounds, tend to persist in water and can also bioaccumulate and biomagnify. Thousands of natural and synthetic organic chemicals are used to make pesticides and plastics and many other day-to-day products. The two most important sources of toxic organic chemicals in water include the improper disposal of industrial and household wastes and runoff. So remember what I said, you may not necessarily see somebody with a big 55-gallon drum like in the back of their truck just pull up to a lake and dump it in, but what we do see a lot is people pouring stuff down drains in homes, okay? Or people using too much pesticide or fertilizers, on their lawns or in their flower beds. And then they turn on the sprinklers and all that stuff goes down the gutter, right? And it ends up in our local waterways. So this is a serious deal. Look at this graph when it comes to the detection of frequency of organic contaminants, right? And just compare what you're seeing there from one product to the next. Next, we're going to look at oil pollution. Oil pollution occurs along coastlines. Basically, few coastlines in the world remain completely uncontaminated by oil. I don't know about you, but probably one of the most frustrating things for me is to go for a walk barefoot on the beach only to find out the bottom of my foot is black with tar or oil. 3 to 6 million tons of oil are released into the ocean each year, about half of which is due to maritime transport. That means that, these boats that are traveling from point A to point B, they leak oil, and there's lots of them. It only takes a single drop of oil to literally make 100 gallons of water undrinkable for people. Major oil spills do account for a lot of water pollution, ocean water pollution, and the occasional oil drilling, event that spills oil into the surrounding seas. But that's not the primary culprit for oil pollution. It's all these boats that are leaking oil from point A to point B. There are plans to drill even in seismically active California and Alaska coasts currently, which if that were to happen and an earthquake occurred, you can do the math. We're going to have a massive oil spill. This just give you a picture of some of what we saw with some of the more significant oil spills that have happened in our past, and we'll spend more time talking about this in a different video. This is part of the cleanup that you can see here from the BP Deepwater Horizon oil spill that occurred back in the earlier part of this century. This was the largest oil spill on record, basically in the United States ever. It took 5 months to cap the well and stop the oil spill. The Deepwater Horizon pumped oil into the Gulf of Mexico literally day after day after day, and they couldn't get to the well to plug it because it was just too deep. Okay. We can even see groundwater pollution as a result of what's going on land. Not just, visible bodies of water like rivers, lakes, and streams, but bodies of water underground. This is MTBE, a gasoline additive that was spilled and contaminated 50% of the groundwater supplies in Santa Monica. The city actually had to purchase replacement water because this MTBE literally filtered down through the rock strata and got into the aquifer, and the rest is history. Okay, the groundwater then began flowing towards the ocean, and yeah, you can imagine what happened next. Okay, so when we think about all of this type of water pollution, there are a lot of interesting kind of like side jaunts that we could go on, and lots of examples of where this has occurred in and around the world, and we're going to spend some time talking about that in class. At this point, we're going to take a break. I'm going to come back for part 2 of this video series, and we're going to explore some other forms of pollution and the laws that are in place to protect our water. I'm Mr. Kennedy, and I will see you in a minute.